Welcome to lecture energy management. So till date we have come to this topic energy management. We have covered some topics over there. So let we will start from the last lecture. So up to this one, what is the need of demand control? The demand control is used because of that the energy bill is comprises of two component. One component is the demand charges and second component is the actual energy consumed by the consumer. So it is become very much necessary to control the demand. If the demand is more, occurrence of the maximum demand is more, definitely the electric bill will be very high. Okay, so it is our duty to control the maximum demand by different methods which we are going to consider one by one. But we have studied what is the advantage of power factor management. So it has two advantages categorized as technical advantage and financial advantage. So technical advantage is that the current in the distribution line will be small. So the rating of switch gears can be reduces. It will reduce the heating effect, failure of the terminals, maintenance. These are the technical advantage. One more very big advantage is that because of the proper reactive power, we are not drawing the reactive power from the source. The voltage profile also very good, or we can say that the voltage of the system will remain as long as constant. The advantage, economical advantage, is that our maximum demand decreases, which will reduce the electricity bill. And second is the whatever the penalties are there, power factor penalties are there, it can be avoided. So this is the objectives and these are the advantage of power factor management. So now we are going to discuss the load control. So load control, first of all we have to understand the load curve. So load curve is always plotted between the power, either it is in the kVA or kilowatt, megawatt versus time. This time may be a 24 hours, so it become a daily load curve. If it is a weekly, so it may weekly load curve, monthly load curve, and yearly load curves. So depend upon the analysis, we will draw the load curve for particular. It may be a consumer, or it may be a for the generating plant. So what are the informations are available from the load curve? It indicates the variation of load with respect to time. Say this is the demand interval where we are going to measure the maximum demand with the help of a smart energy meter. It is going to measure every 30 minutes what is the maximum demand. So suppose it is the interval of 30 minutes, this is interval of 30 minutes are there. So this is the time axis and this is your actual power. It is maybe in kV or kilowatt is there. So it will show the variation of demand with respect to time. This is one parameters. It will show what is the minimum load on the system and what is the maximum load. The duration of maximum load is how much we can easily calculate, or easily it is quite clear from the load curve. And one more thing, the area under load curve is nothing but the number of unit or number of it is the energy supplied by the generating station, or if it is a consumer, energy consumed by the consumer. Suppose it is in kilowatt and it is in time in hours. So kilowatt multiplied by time, it is nothing but the energy. Suppose it is in the megawatt and it is the hour, so megawatt hours is, so it is a simple, it is a energy. So area under curve is nothing but the energy. And if it is measured in kVA, so it is a kVAh. Now it is the kVH billings are there, so it is also quite clear. So it will give the number of information from the consumer side as well as the energy supplier side. It will show this is the maximum demand and this is the minimum demand, or this is our average load. If you add this one, is the average load is there. So this is the average loads are there. So we can calculate the load factor, average load divided by maximum demand. So it will show the load factor of the, it may be a generating station or the consumers are there. Okay. So it will show this is the base load. It will remain present in on the system throughout 24 hours, or it may be yearly. So it is a base load for the power plant. Yearly base load power plants are there. So these are the number of information we can get from the load curves. Now our objective in the energy management, or especially for the load management or demand side management, we want to make the load curve as flat as possible. No doubt it will not be a flat 100% flat, but again there is some dips are there, there is a valleys are there, somewhere hills are there. So we want to reduce this maximum demand and we want to fill this valley. So under such condition your load curve become as flat as possible, and it indicates that it is the proper utilization of infrastructure. Under such condition also, the unit rate or the generating cost, relative generating cost will be smaller if your load curve is flattened. Okay. When the load curve is somewhat flattened, your load factor will be towards the unity, isn't it? For example, this is the 100 megawatt and it is the average load is 50 megawatt. So we can say that the load factor will be only zero point 0.5. Whereas the maximum demand is 70 megawatt and average load is 60. So 60 divided by 70, so it is very much near to the unity one. So therefore, it is very much necessary to change the profile of customer by scheduling of load in such a way that the load curve become as flat as possible, and this concept is known as demand side management. Okay, so we will see one by one how to achieve the demand side management. This is the uh, load duration curve. In the load duration curve, again it is the kilowatt, it is a kVA, whatever it may that value, and this is the times are there, particular times are there. But in this case, what we will do, we will keep all the maximum demand in the left side, and we will arrange the load in such a way that the load is go on decreasing. So from this one, it is quite clear that what is our load curve, what is our base load is there, what is our average load is there, and what is our peak load is there, and what is the time or the time interval for the maximum demand or peak load. So it is found that for the peak load or peak load capacity is going to occur for a very small period of time, say for example 1 or 2 hours is there, or it is occurring from 6 p.m. to 10 p.m. So what would be the uh, say method to cope this or to fulfill that demand? We can start our DG sets, we can start our pump storage power plants which can be quickly on and quickly off. So this will indicate that it will help to schedule the different combination of generating plant also. So as we have already learned in the power systems and power plant engineering, load scheduling between the different type of generating units, it may be a thermal and hydropower scheduling, thermal and peak loading, that is a pumping load is there, pumping pump storage power plants are there. So this is the things which can be used for that purposes. Now, how to achieve the demand manage or demand control or demand management? So demand management can be achieved by some, first is the power factor improvement, which we have already considered in very detail. What are the advantage of improving power factors, technical advantage and economical advantage? Second is the rescheduling of load. We have to second is the rescheduling of load, we will see one by one. Second is storage product. What is the storage product, we will see one by one. Okay, scheduling of non essential feeders, operation of captive generation or diesel generating set, and reactive power compensation. So power factor improvement, first point we have already covered, so we will not discuss much more over the power factor improvement system. Now second point is the rescheduling of load. If you reschedule the load, definitely we are able to reduce the maximum demand. Say for example, we will go to the this figure. In this figure it is found that this is our maximum demand, and it is occurring from say 6 p.m. to 10 p.m. This is our time. Say for example, this is 6 p.m. and this is 10 p.m. So which type of loads are on during that time? For if you consider industry, so lighting load is on, pumping system is on, your refrigeration plant or storage plant is on, production unit is on, material handling plant also it is in the running condition, or we can say that entire system under running condition. So because of the this time, your additional lighting load and then all this load are simultaneously on, so your load is higher during that time. So we have to schedule that load. So can we stop our production? No, because it is going to hamper the quantity of production. Can we reduce some process, that is the utility sections are there, that is a compressed air, it is a chilling plant, or it may be some boilers are there? No, because it is going to maintain the quality of the product. And energy conservation, what is our basic line of energy conservation? The basic line of energy conservation is conserving energy or saving of electrical energy without loss of or without compromising the quantity, quality, and comfort level. So we do not want to stop our production. We do not want to stop our utility because it is going to affect over the quality of the material, quality of the product. So our pumping system, it is not necessary to run in the evening times. We can run into the night time from 10 p.m. to morning 6 a.m. We can run our effluent treatment plant. We can use storage system. What is the storage system? Is that is the pumping of the water, doing some say keeping cold and hot places, that is the oven systems are there. It may be some refrigeration units are there where we are going to freeze some material if it is a process or food industry is there. So if you use or if you schedule that load, if you shift the pumping time to the pumping load to the other time, effluent treatment plant to the other time, definitely we are able to reduce the load. So if the pumping load and your effluent treatment plant is going to run in the different time, then your maximum demand during that time it becomes somewhat smaller. Say this is your maximum demand. So by doing rescheduling of load or scheduling of the load, shifting to the other time, it will reduce our maximum demand. So this is the one way to control the maximum demand. Okay. Next is the storage product. So what are the different type of storage products are there? Say for example, if we required some cold storage power system, so we will run our chilling system, we will run our refrigeration unit in the night time. And what is the maximum load rate is higher one from 9 a.m. to 12 a.m. Okay, in the daytime 9 to 12, and evening 6 to 10 p.m. So if we are able to stop our refrigeration plant or cold storage plant during that time, it will reduce the maximum demand occurrence as well as it will reduce the energy rate. So again we will go to the this one, so it will become very quiet from this ppt. Yes, in this case it is found that from 6 p.m. to 9, that is morning, sorry, 6 a.m. to 9 and 12 to 6, there is no addition of um, rate in the basic rate of energy. Whereas morning 6 to 12 plus 80 paisa is get added. So if we are able to reduce or if you are able to switch off our refrigeration plant or cold storage plant morning 9 a.m. to 12 noon, so definitely the consumption also get reduces and extra in unit extra money which is going to added in the basic rate of energy also get reduces. Second parameter is 6 p.m. to 10 p.m. This is the peak period which is occur not in your premises in the industry but all over the generating station, because all residential lighting load is on, commercial load is on, street light is on, everywhere the light, no doubt lighting load also very high on the power systems. So during that time your load will be very high or maximum demand is going to occur. But up to 10 p.m. or the commercial load is going to switch off. So under such condition we have to pay more rate, that is the additional rate of 1 rupees 10 paisa in addition to the basic unit or basic rates are there. Okay. So if you are using such type of storage system where we can store the cooled air, we can store the cooled, keeping the water at particular temperature, and if will remain possible to maintain the temperature, we can switch off that such type of load during 9 a.m. to 12 noon and evening 6 p.m. to 10 p.m. So in this way, by using the storage system, we can reduce the maximum demand or we can control the demand over the system. This is possible for the hot water also. If we need somewhere hot water up to the 70 degree, we will keep the temperature of up to the 80 degree or 85 degree, and we can run our plant in the night time, and morning 9 to 10 9 to 12 noon we will switch off the heating load. Similarly, in the evening we can switch off the heating load. So this is quite possible by using such type of storage system. Okay. So this is called as a utility like refrigeration process, especially is a refrigeration we are using for that one. I come to know in one workshop is that many of the some say for example they have given the example of stock exchange market. In the exchange market, they are keeping ACs on position in the night time, and in the daytime they will switch off some of the ACs are there, because whatever the storage cooled air is there, it is going to utilize in the daytime. So by this way we can use the storage system. Second is the scheduling of non-essential load. Whatever the non-essential loads are there which is not necessary to run during that time, it can be shifted. It does not affect the quantity of product, quality of products. So definitely we should shift that load. For example, water pumping system, it is not necessary to run in 9 a.m. to 12 noon, as well as 6 p.m. to 10 p.m. Okay, we can shift to the night time. We can shift to the 12 noon to the 6 p.m. Okay, during that period where the additional charges will not to pay, or it is better to run in the night time, because during that time we get the benefit of 1 rupees 10 paisa, 1 rupees 50 paisa get subtracted in the basic rate of energy. So effluent treatment plant is the same, water pumping system is same, other raw material handling also be the same. So we can do such type of work in, we can shift into the night time, and it is a less priority feeders. Okay, so this is called as a, say for example our college also, it is not necessary to run the power to run our pumping system during 10:30 to 12. It is always found that as soon as the college start at 10 or 10:30, people are came to 10 or 10:30, they will start their load, including the pumping system, including the garden pumpings are there. So instead of that one, we can shift to the night time, we can shift to the off peak period, and hence we are able to reduce our maximum demand. Next is the captive operation of captive generation like diesel set. Okay. Say for example, in our plant, it is found that in the some particular period of time, says 6 p.m. to 10 p.m. or other time is there where the maximum demand occurs. So what we will do, we will shift the load of utility, we can shift the load of some other feeders to the separate generator. So as soon as we will start the generator, because it can be started very easily, it can be stopped very easily, or in a very particular period, small period of time. So as your maximum demand is going to occur only 1 hours, so why to pay more money, more electricity bill only for 1 hour in a day? So we can start our DG set. We can shift to that some part of the load to the DG set, and once our maximum demand decreases, we will switch off the load, switch off the generating unit, that is our generator DG set, and again we will shift to the our grid system, regular grid power supply. So by this way, we are able to reduce the maximum demand. Or what we can do, we can use some demand indicators are there. Okay, so just a minute. हेलो. हाँ, डिपार्टमेंट में हूँ, जरा लेक्चर ले रहा, 10 मिनट से मैं फोन करता हूँ. हाँ, 10 मिनट से करता हूँ. Yes, sorry. So the second method is that we can install a demand controller. The demand controller, say for this one, we will take example is that our maximum demand is 300 kVA. Okay, we will set our maximum demand controller as equal to 290 kVA. As soon as the demand increases to 290 kVA, it will automatically switch off one of our feeder. Now we have to choose that which feeder to be switched off. We will take example of our college. There are number of feeders are there. College building feeders is there, office feeders are there. Okay, then workshop is there, electrical mechanical building is there, hostel number 1 2 3 like that are there, isn't it? It is somewhat, it is a general distribution of any college or any institutes are there. Now it is going to observe that in the morning time 9:30 to say 12 or 12 to 30, 12 to 4 p.m, the maximum demand is going to occur. So during daytime, which is our less priority feeder? The less priority feeder is one of the hostels, because all the students comes into the college. Okay, we can switch off feeders. We can switch off residential feeder. Okay, so if your residential feeder is going to switch off, there is a no harm. There is a no effect over the teaching learning process are there. We can switch off say 1.5 hour for the residential feeder. So only switching off one of the feeder, your maximum demand again decreases. Once the maximum demand is less than our less it is reaches to the our some particular level which we have set, again your uh, residential feeder is going to switch on. So by using some demand controller, it is available in the market. If you use such type of demand controller and their signal is given to the different type of MCCBs by using some shunt release coils, definitely we can reduce our maximum demand occurrence, and this is also one of the way to reduce our maximum demand, and that is nothing but the demand management. Next is the reactive power compensation. The reactive power compensation is by one way is the centrally you can do the reactive power compensation by connecting automatic power factor controller at the center level, at the substations are there. Again, it can be used, suppose there is a number of heavy machines are there, we can use individual capacitor, individual reactive power compensator at the load side. So it has a one more advantage, it will decrease the reactive power flow from the your substation to the load center. Suppose your substation is far away from your say process plant is there. Okay, and if you are running your 50 HP or 100 HP motors are there, if you connect the capacitor near to the three phase induction motor, whatever the kVA are lagging required to the motor, it is going to supplied by the static capacitor, because it will deliver the reactive power, leading reactive powers, isn't it? When it is delivering reactive power locally, there is no need to draw the reactive power from your substation to the load center. So it will decrease the current in the cable, which will decreases the losses. Second, it will decrease the capacity of switch gears. Okay, so it also play, if you are controlling the reactive power locally, definitely it will improve, or it will maintain the demand of the system. So this is the different way by which we can do the demand management. Okay, so now I will stop here, and next time we will start the demand side management.